Hi everyone. So welcome to this shared presentation between the second workshop of the Elite Society and Big Science episode 1, which is actually also the second live event of Big Science after the kickoff event. So in this presentation, I'll give you a bird's eye view of the Big Science research workshop, this 1 year long project. This will be focused on the reason we created Big Science, the reason Big Science kind of started as a project. And if you want to know really more about what happened over the past few months in the working group, I encourage you very strongly to check the presentation, the paper, the posters of the working group after this session, so that you really know about the technical. Here I mostly focus about history, why it was started, and the general organization. I have a few slides, so let's go with them. Okay, so the full name of BigScience is actually the Summer of Language Model 21, which is a reaction to the AI winter, right? So what was the inspiration? Well, we see in many scientific fields that there are very large research tools. And a good example is the Large Hadron Collider, which is this very expensive particle physics research tool, which was built by about 10,000 researchers from 100 countries. It led to the discoveries of many particle physics and the publication of about more than 2,000 papers. And actually, we see that in many fields where basically large-scale worldwide research collaboration create these tools that are really useful for the entire research community. So the LHC is the biggest example, but you also probably have heard about ITER, which is this nuclear fusion research reactor, or the ISS, the International Space Station. And basically, the question here is maybe it's time to build some similar large, diverse, open research collaboration in AI and NLP. And why would this be the time? Because if you're in the NLP field, you've probably seen that many recent developments involve training very large language model on large data sets. And typically the compute research are only found in industries. These are just not accessible for like academia research lab or just small research team, even in industry, right? And this poses a number of issues. There are issues related to research, right? These models are usually not designed as general research tools. So it's very hard usually to get access to the training data. Sometimes they're even private model, right? So you can't really investigate what's happening in them. And basically a lot of research questions you want to ask are just asked after the training of the model, right? It's difficult also to involve academia here. Most of these models are trained without any university team. And there is a general lack of diversity in the field. Environmentally, it's a little bit strange that we duplicate all these trainings on models that are honestly really similar sometimes. The carbon footprint is obviously not usually not very well documented. And there is a number of ethical, societal questions around the text corpora that I use that are very often not a major focus of projects. And that where we have seen after the facts a lot of shortcomings in terms of representativeness of population, this type of question. And basically a lot of questions related to ethics, bias, fairness, usage are just asked a posteriori. And so the general idea here is that, well, there exists some large-scale public compute infrastructure. And a very good example is Jean-Zay, which is a supercomputer in the south of Paris, and who has about 2,700 with 100 GPUs. So it's fairly powerful, and it's definitely powerful enough to train one of these very large language models. It's also usually very environmental friendly because it's designed from the ground up to be kind of efficient. It's a supercomputer, right? It's not just a cloud compute. So the short history of the Big Science started not very long ago, actually in early 2021. You have a couple of discussions between me and Stéphane Requena and Pierre-François Lavallée, who are respectively a member of GenC, who was the builder of Jean-Zay, and Idriss, who is the operator of Jean-Zay. And we discussed how this actually compute infrastructure could be used to create like general research tool, like a very large multilingual language model. And so very quickly, we discussed about that in Hugging Face with the French community, with the French academia and industrial labs. And they were very interested in joining forces. And so a few months ago in February, we filed a grant application for 5 million GPU hours, which we estimated to be enough compute to train a model that would be interesting in terms of the research experiments we could do with it. And so following the grant submission, we opened and extended this collaboration to the full international research community. And we started to structure this organization as a research workshop, by which I mean that it's a very open organization with a very weak structure, and basically where it's easy to involve people from various backgrounds. It's also very easy to structure that in I would say more typical research thing, for instance, to allow for publication of paper, to have a proceeding venue. So there's a lot of advantages to this. In mid and late April, we heard that the grant was accepted. And so we set up a first kickoff event, which was the first live event of BigScience, to kind of gather everyone, to present a little bit first ideas of working group inside the research workshop. And today, it's very nice that we can do the second live event, which is called episode 1, where we expect to present the first results and work on preliminary work of the working groups in BigScience. So this is co-located with second workshop of ELIS NLP, the ELIS Society in Europe, which I think is really nice, because one of the idea of BigScience is really also to kind of blend in the existing landscape of network, of research organization, and to be an active participant rather than, I would say, a competitor or like a totally distinct entity. Here, the idea is really to establish connection, to be a hub of discussion. So the core research part here is that large language model and large data set exhibit some intriguing and surprising behavior from a research point of view. They raise many research questions, which are interesting. For instance, fundamental question around what are the limits of what can be done with purely statistical co-occurrence, I would say, based approaches. The notion of what is an NLP task is interestingly challenged by the zero-shot experiments with this very large language model. What is the relation between the task and data set? And in general, they have been surprising for many people in the community. I would say that they could do some of the things that they have been shown to be able to do. There's a lot of question around bias and fairness in these models also. Is this how can this be related to training objectives, the data set used, and how can we also make sure this model encode maybe the least amount of bias of stereotypes? There is a lot of question around memorization, which are interesting both from fundamental point of view and from more applied point of view of personal identifying information memorization. There is obviously a lot of question around the environmental impact of training these models and the carbon footprint, which is not as well documented as it could be as well. And there is also a lot of other questions, I would say, that are really interesting and very much underexplored today, given the difficult access to this model, like interpretability, visualization of what's happening in these models, of the training regimes, relation to cognitive processes, and many others. These are just basically my personal favorites. So the concept of BigScience was just to try to gather a very large research community around the creation of one of these artifacts, so that we could consider in advance the research question that would be interesting to answer. So we could just reflect, we could prepare the tools that we would need to answer this question. And basically the idea is here to ask the question a priori rather than a posteriori, so that we can, for instance, save needed artifact to answer some of these questions, right? If you want to know memorization, it's very interesting if you can save some checkpoints to understand when it arises during the training, for instance. The second point important is to create this artifact and to share them with the scientific community. So to find way to share a very large multilingual corpus, which is also raise a very large number of questions around responsible sharing, diverse. There are legal questions, but also ethical questions. And finding some solution to this question would be very interesting to be able to do some research on this model in the future. There is also obviously the idea of sharing a large language model as an object of study for all researchers, and also all the code tools associated, for instance, to make this very large language model easy to use in a research project on maybe small workstation. And more generally, it's a scientific endeavor. So there is all the interesting process of building knowledge around how we do that. And the very meta approach of, if this kind of collaborative open research is successful and interesting, we should document how it was done and what could be done better about this in the future. And so that people who want to do maybe next year, maybe in a few years, another collaborative research event like this could have like a good example and a lot of documents to start from. So as I said, BigScience is structured as a workshop. So what does this mean in practice? It means that beside the collaborative tasks, which are the creation of the data sets, the model, the tools that comes with them, this project is also a workshop. So it will be conducted online. We have a few live sessions like today, which are here to kind of gather people to foster discussion. And also we try to make it easy to present the work done. So to have proceedings, to have publication, to have poster, just like a regular workshop, right? And the idea is even to open this more to the public so that people who are not NLP specialists can understand a bit better what are these models, okay? Well, more than everything, I think this project is a big blank page that is open for new ideas and how it could be, how we could do research in maybe a little more collaborative way in the community, right? So in practice, how it looks, because it's a research workshop, everyone is kind of part-time involved. So there is various roles that involve more or less time commitment. There is some general advising people who are just kind of following the newsletter of the project and kind of give some general advices from time to time. The time commitment is very light. And most of the people are actually in this role, which is very nice. That's the idea, is just to keep everyone aware of this happening, to share all the knowledge created during the workshop. And if people want to react and participate, it's also very easy for them. So the main way people can participate is to join a working group. So there is two ways you can participate in working group. You can chair one, which is maybe the role with the most involvement, I would say, where people will organize the discussion, kind of lead the brainstorm, and also kind of organize the experiment. A lot of people are also just participating as a workshop, as a participant in a working group. And the last role that we have not explored very much yet, but which will be very interesting in the coming events, I think, is for like general workshop attendants, which are people not participating in the workshop and who are just trying to join the live event to understand what's happening, participating maybe on some more community-oriented collaborative tasks. But these are things that are still open to be pursued, I would say. So today we have a lot of working groups. There is about 25 working groups active, about 46 chairs. The working group are very free to organize themselves as they want. Most of them have bi-weekly meetings. The working group chairs also meet to discuss every 2 weeks. And basically the working groups, the chairs are a bit the contact points between the various working group to make sure that the information that need to be exchanged is exchanged. Several participants are also involved in a few working groups and can help also making sure that everyone is on the same page. So I just present briefly all these main working groups. So one main area is data set, where there is a strong focus on the social aspect of the data set, respecting the right of data subjects, documenting the data set. There is here the idea of spending the necessary time to make the data set very useful research in the future. So because of the size of the task, right, the original working group on dataset has been split in 3 working groups in this area. The first one, who has been really active over the last month, is the working group on data governance. Basically how we can kind of store this data. Well, that's one aspect of what they do. They do much more. The second one is data sourcing, right, which is a task with finding the right source for the data. And the last one is data tooling, which will be in charge of kind of filtering this data. So obviously all this area, all this working group are working in close relation. Many people are member of both or 3 of them. The second large working group is the modeling approach, which is also so large that it has been split in 5 working groups. And here the moonshot goals is to try to answer any natural language prompted query in natural language in a zero-shot manner. So here there is a research goal around investigating in depth this zero-shot behavior and trying to see if it can be in particular more robust to the language of the prompt. But there are many, many more areas. So this specific focus is the focus of the prompt engineering working group, but there is also a working group working on multilinguality, because this will be a very important aspect of the created model. There is a working group investigating how retrieval could be used at some place in the model or during training or inference. There's a strong focus on metadata, which I think is very interesting. And obviously the question of the architecture of the model and the scaling laws, right, is now very, has already been investigating quite deeply, I would say. Another very active working group is the group on tokenization. So here, this is a kind of presentation of tokenizer, but I assume that most of the people here are like NLP practitioners, so you obviously know what is a tokenizer. It's a very important element in the processing pipeline, right? That will define also, that will be very important for the behavior of the model. And in particular here, since we target a multilingual model, there is a number of essential design choices that have to be made here. There is a lot of challenges, okay, on tokenization. How can it be massively multilingual? And a general question about, can we build better tokenization than what we have seen today in this multilingual setting? Another very active working group is the one on visualization and interpretation. And here I encourage you to kind of check what they have already kind of presented today. They will be very important because all these large tools can open the way to super interesting visualization. And there is in particular a very active subgroup on training dynamics. Another huge area, obviously, is evaluation. Evaluating these language models span diversity of area, I would say. And there is this question about how can we design the multifaceted suite of evaluation to kind of understand in details and along all the possible axes how this model behaves. So this is a working group that is basically expected to be very active during the 1 year, but also after that, because obviously just creating this model is the beginning of trying to understand them as a research tool. And so right now they have been splitting this very large area in 5 working groups. One is based on extrinsic task-based evaluation, basically how will the model perform on the various tasks that are interesting for the people participating in research workshop. There is some question around just intrinsic evaluation, and typically one example is perplexity or things like that. There is the very important question of generalization or robustness. We evaluate we are interested in the zero-shot behavior of these models. So how can we evaluate them? And how will the model behave here? Here, like everywhere in the workshop, there is a strong focus on trying to pose the social, ethical, the social impact question first. And so like the dataset group, like also the modeling group, actually, the working group on evaluation is also focusing on this. What bias will the model encode? How can we evaluate that? What are the risks of using this model outside of a research setup? And multilinguality is also something that the research workshop is trying to pose as a first requirement and not a posteriori question, right? How can we be sure that our evaluation procedure is not too much biased on English and is actually a fair multilingual evaluation of the model? There is a meta-level working group focusing on the social impact, and instead of being just a separate place where this question is discussed, it's actually gathering chairs from many other working group, and the idea is to kind of coordinate and make the idea of social impact evaluation diffuse in the whole research workshop. So here again, I encourage you to check what this meta working group has been working on in the past few months. They made in particular a very interesting survey of the participants of BigScience, which obviously is the meta approach, right? But that's the important one, because if the participants of BigScience are not diverse, it's it's a bad sign about the diversity of what this research workshop can produce. There is obviously a working group on engineering and scaling, because this is a large language model trained on very large supercomputers. So there is a lot of question around how can we scale the training efficiently, in particular, given that the compute budget is given in GPU hours. We need to make sure that the GPU don't stay idle most of the time during the GPU hours. So there is a very interesting set of technical challenges. And this working group is working very closely with the Jean Zay technical team, with Microsoft DeepSpeed and NVIDIA Megatron. And they have already done a lot of experiments since May, and are currently training a first significantly large model to try to move to the next scale of training. There is a working group on collaboration. As I mentioned, the BigScience is not seen as like an isolated island, right? It's seen as participating in the network of already existing organization about research, about education. And at some point, we would like to be able to make the general public, layman people, to open a door to what this large language model means. What is this kind of new technology? And so this working group is actually one of the reasons we are co-locating this event today with ELIS NLP, because the ELIS Society is a very important network in Europe, and we think it's important to connect with them. It's also another reason why we are co-locating with INLG in September, and everywhere we can do something together with some organization or some network that's already existing. It's very likely the good solution. There's a specific working group on carbon footprint, trying to take advantage of this very open training to have better understanding of the carbon footprint of building this model. And there is also a working group on biomedical domain. Biomedical is one of the most, I would say, practical application of AI in another scientific field today. We've probably seen, right, the protein foldings, for instance, things. And the idea here is also to make sure that this large language model is also useful in the biomedical domain. For instance, that it knows the right words and things like that. So this is just an overview. This working group are still can still be created. There were several proposals last week to create new working group that I think are also very interesting. So some of them have changed names, some of them have been evolving a little bit, but generally they've all been doing like a really impressive amount of work over the past few months. And if you want to know more, I really encourage you to check the video. They're all recorded and can be accessed later, the poster that people will present today. And you will know a lot more about what they have already accomplished and what they plan to do next. And the next live event will be in about 2 months, and will be, as I mentioned, co-located with INLG, which is happening this year in England, in the United Kingdom, but which is obviously mostly online. So we also plan that the next live event will still be mostly online. And the idea here will be to present some work that could not be presented in July, to present what the working group have been doing over the summer. Some people have more time during the summer, and just to gather another time to share a few discussions about the topics that we cover here. So thanks for listening. If you want to know more about today's events, here is the web page. There's also the BigScience websites and the Twitter. And if it's the first time you hear about this adventure, well, know that it's a 1-year research workshop where the goal is to create and share a very large multilingual data set and a very large multilingual language model for research purposes. The idea is to foster research and discussion brainstorm around large language model, and can pose every question from the start. And these questions spanning typically a much wider field than just, I would say, modeling question. So with about 500 participants, I think it's actually more than that, from 50 countries, there is 5 million compute hours. And generally, I think this is just the largest collaboration that ever trained together a language model. So it's a very exciting endeavor. Thanks a lot for listening. And I encourage you to check all the things that are happening today in the BigScience episode 1 event. Thank you. Bye-bye.
Welcome to our introduction of the BigScience modeling group. I'm Steve Bach, along with Victor Sanh, and we are the area chairs for this group. In this short video, we'll give you a quick overview of the modeling group and pointers to the various presentations of the sub-working groups during this workshop. So the modeling group is an umbrella group of sub-working groups. They're all conducting research and making recommendations on different aspects of the model training. This includes what kind of architecture to use, what types of inputs to give the model, and how to model multilingual data. A lot of these areas overlap with other working groups in BigScience, so we coordinate closely with them. We'll now go through each of the 5 sub-working groups. First is architecture and scaling. This group is all about the question, how to get the best bang for our bucks with our training. In particular, they are investigating questions around multilinguality in extremely large language models and a variety of architectural design choices, such as bringing benefits of encoder-decoder models with prefix language models. They're working closely with different groups within BigScience to measure scaling laws of optimal compute and model size to our training, and validate the scaling laws with in-depth evaluation. So this group will present a poster in a few minutes in the second poster session. Our next working group is the metadata group. This group is studying the wide range of additional information that can be provided as input to the language model about where the text came from. Everything from the URL from which the data came to control information like how long a completion is desired is under consideration. The goal is to enable more controllable text generation and improve zero and few shot capabilities. The metadata group will share some of their work in a video coming up shortly.
The multilinguality working group is a meta group inside the modeling working group. They coordinate with other working groups and formulate recommendations and strategies to best approach multilinguality so that all modeling questions are extended to multilingual setups. For instance, the group is interested in understanding how to address the trade-off between better cross-lingual performance and degradation in performance as the number of languages to model increases. The group is also exploring whether we can easily add new languages to the model once it is trained, and what architectures and mechanisms would be suitable. This group presented at the poster session earlier today. The next working group is prompt engineering. Prompt engineering is a hot topic in NLP right now, as researchers explore all interesting behaviors that can be elicited from language models by finding the right input. Our goal in this working group is to study what happens when we train a large language model from the beginning on many examples of prompts for task-oriented behavior. Ideally, the model would be better suited for few-shot and zero-shot learning, perhaps generalizing to new tasks more quickly. To do so, we developed and open-sourced a repository of over 1,500 prompts templates for over 150 datasets. We are in the process of using this dataset for pilot experiments and to study generalization to new tasks. Come talk to us in the afternoon poster session to learn more. The last working group studies dense retrieval mechanisms. This group is interested in the question of updating the knowledge of language models after their initial training. For instance, a language model trained in 2018 is unlikely to know anything about COVID-19. The group is exploring the extent to which retrieval can provide up-to-date context to very large language models, and where and how to find this context. Another application of this is improving performance on zero-shot settings, where a model is tasked to answer a query expressed in natural language in natural language. This group presented at the poster session earlier today. We're excited about the work that all of these working groups are doing. If you are too, come talk to us at the various breakout and poster sessions. All these working groups are looking for more collaborators, so additional help and input is always welcome. Thank you.
Hello and welcome everyone to the talk of the Modeling Metadata Working Group. My name is Nora and I'm a PhD student at LMU Munich.
And I'm Timo, also a PhD student at LMU Munich, and together we co-chair the Modeling Metadata Working Group.
So what is our working group all about? We are exploring different ways of including metadata during the pre-training phase of the model. So the idea is to use any kind of information which is associated with the raw text we are training on and pre-appending it to the training batches. And the idea here is that this can enable more controllable text generation and also to improve zero and few shot capabilities of the model. Obviously, we are not the first one to come up with this idea. There's an extensive related work. Here we list a few examples. If you're interested, please refer to these to get more detailed information on how to use metadata during pre-training.
So let's look at one example of how we might use metadata or how it might be helpful for controlling what a language model does. And we will look at timestamps. If we ask a regular language model, the president of the United States is, then depending on when and on what data it has been trained, it might output something like Joe Biden, and we don't really have any control over that output. But if we included timestamps during pre-training, we can, of course, also use them when prompting the model. And so we can additionally add the information that we are interested in a valid output in the year 1719, in which case the model might produce George Washington, or in the year 2010, when it would hopefully produce Barack Obama. So this is one additional handle that allows us to control how the language model behaves. And as another example, we can look at the data source type. So again, during pre-training, we might tell the language model whether we wanted to produce some text that is from Wikipedia or from a newspaper article. And then we can also use that information during prompting. And for example, we might ask the model to produce a continuation for Joe Biden in the style of Wikipedia. So it might say that he's an American politician and current president of the United States. But we might also ask it to produce a text that starts with Joe Biden and is in the style of a newspaper, where it might say he visited Europe on his first overseas trips or something similar. So again, this is another way of controlling how the language model behaves in a zero or few shot fashion.
Now, these are two examples of how metadata can be beneficial for generation. Here's a list of all the other options we are currently exploring. Again, this is not a complete list. We might add additional candidates later on as part of the progress of this working group. And now in the following, we have a few of our group members. Obviously, it's not Timo and me doing this all alone, who are going to present some of the details of a few of these metadata candidates.
Hi, I'm Manan. I'm currently working at SAP Labs India and a part of the metadata working group at the BigScience workshop. The metadata I'm currently looking at are entity tags. From previous works, it can be seen that using entity tags as metadata can be useful in many ways, a few of which we'll discuss in some time. There can be various ways in which we can use entity tags as metadata while pre-training a language model, some of which are: while pre-training a language model, we can replace a few random entities in the text with mask entities and train the model by letting it predict the actual entity that has been replaced by the mask entity. And this would make the model learn contextualized representations effectively. We can then try to evaluate the efficacy of our trained model on entity-related natural language tasks like named entity recognition, relation classification, extractive question answering, etc. Another way to use entity tags as metadata while pre-training a language model is to control the generation of text based on entities of interest. The idea here is to prepend a list of dominant entities to the source text separated by a special token. Then the model needs to be trained in such a way so as to maximize the probability of generating a text that is related to the most dominant entities. This would enable the users in performing controllable text generation based on their entities of interest. Similarly, we can use topic tags to train the model to generate variations of text based on a particular topic when the entities into consideration are the same. Additionally, another idea would be to append some useful information regarding each entity based on the context, which might act as a form of conditioning for entities that are rare and for which much information is not available. This might help in improving the retrieval capacity of the model. As we can see in the example in the slide, different variations of text get generated when we use the same entity but different topic tags. A few advantages of using entity tags as metadata over other metadata is that they are easier to fetch through various methods like entity linking, etc. Moreover, it is possible to gather such metadata for multilingual datasets as well. A few of the previous works related to using entity tags as metadata are mentioned in the slide.
Hi, I'm Shania. I work as a software developer at Walmart Labs India, and I'm a part of the metadata working group at the BigScience workshop. I'm currently working on using website descriptions as metadata. So previous works like CTRL have used URLs and domains like politics, reviews, etc. to gain control on the style of the generated text. We want to conduct experiments to understand if providing descriptions of the sources will enable an even more controllable text generation. We plan to use the about sections of websites and external sources like Wikipedia to gather the descriptions. The handle and the channel description on platforms like YouTube and Twitter can also be a good source for the same. The impact we expect to see from such descriptions is in the style of the generated text. For example, for an input Olympics, website description for Wikipedia should generate a more informative text, whereas for the same prompt, the website description for New York Times should lead to a reporting style associated with the text generated. We also expect to control the model from going off track and generating malicious data. Or at the very least, we expect to keep it restricted to certain sources. Few ideas on evaluating the variation is to compare the perplexity of models with and without metadata. Apart from that, having a separate classifier that would predict the source of the generated text can also be a good way to validate. That said, we are open to ideas, so please reach out to us in case you have any other ideas for the same. Thank you.
Hello, fellow BigScience participants. This is Mike from Tokyo. After finishing my PhD about Chinese word syllable segmentations 9 years ago in Taiwan, I started working for a series of startups in Japan. They were about machine translation or data science in general, and my current one is for chatbot. Like many other companies in chatbot business, we really want to explore further for natural language generation, hence my effort here about URL metadata. An URL is an integral part of online text, therefore a convenient type of metadata. Here the table, derived from the paper CTRL, shows some nice features when using URLs for conditional text generation. For example, years intersecting terms of office lead to different person names, such that an URL with 2007 presents George W. Bush and Tony Blair, while another one with 2018 covers May and Trump. What interests us include but not limited to: were they effective and true at scale? What tokenization tactics should apply? Would it be useful without pre-training? And how about classification tasks? We'd like to conduct analysis and experiments for better understanding of those questions and beyond.
All right, so I hope the past few minutes have given you an overview of what our group is working on. Of course, apart from the things you've seen, there are many more things that we would like to explore and many more open problems, like looking at HTML tags, looking at data source types, at generation length, language, and so on. And of course, we need help for that. So if this sounds interesting to you, if you want to help, please feel free to reach out. You can find our contact information on this slide.
And thank you so much for listening to our talk, and we are looking forward to get into contact.
Hello, everyone. This is the July update of the Tokenization Working Group of the BigScience project. It will be led by Samson from Salesforce and the National University of Singapore, and by myself, Benoît Sagot from INRIA Paris in France. The motivation of the Tokenization Working Group is that language models need to process individual atomic units, often called subwords, that belong to a fixed size vocabulary. And defining how to create that vocabulary of subwords and how to tokenize the training corpora into these subwords is called today tokenization, and this is what this working group is about. More precisely, our role as a working group is to be able to take raw corpora covering multiple languages and scripts as an input and to tokenize them using the best possible strategy as identified by a number of metrics and considerations. In particular, we would like to select a tokenization algorithm and vocabulary that optimizes the performance of the final language model in a way that is as fair as possible for each language and each script. Our place within the project is a little bit in the middle, this little green group that benefits and takes as an input the result of the work by all the working groups, sub-working groups in the data working group, and that will provide the modeling group with the data the tokenized data they need to train the model. Today's presentation will be mostly divided into 3 parts. In the first part, Sabrina Mielke will present a survey of tokenization methods and training strategies that we have been working on in our working group. Then Samson will describe experiments that we have carried out to measure the effect of corpus size on tokenizer training. And finally, Romain Castagnier will describe the scaling law experiments that we plan to do in the near future for tokenization evaluation. And finally, Samson will give a few words of conclusion and perspectives for our working group's job.
Okay, I'm going to briefly talk about the survey that we've been trying to put together on open vocabulary modeling and how it relates and leads to modern tokenization efforts. So this is work with a lot of tokenization working group members in the BigScience project. I put some names here, but we still have people coming in and writing new stuff, so it's probably going to be a number of people in the end ending up on what we're producing. So what are we producing? Well, we right now have a draft of what hopefully is going to be a kind of survey paper, a kind of lit review paper. As you can see, there's lots of to-do notes in there, but it definitely is looking like something. So let me just give you a quick overview of what this is going to be trying to cover. One of the things you might want to check first is like, okay, well, what kind of things are we talking about? Are we only looking at work from like recent years, or are we going back a little bit? And as you can see, in terms of citations, we do go back a little bit, but it's definitely focusing in particular on like the neural era and the subword tokenization era. So what is tokenization? That's kind of the first question that we want to answer, and for this draft we take the position that it's basically whatever we treat as an atom for our processing, anything that is going to be basically integerized when we look up embeddings, or even before then, just treat it as an kind of a terminal node in processing, as Webster and Kidd call it. Or to kind of put a funny spin on it, this GPT-2 generated tweet is perhaps not quite what they meant when they're human creating this tweet, but I love it. Tokens are not a real thing. That's kind of true. Anyhow, so this is kind of some of the approaches that we want to be covering in this survey, some of the things that we might have heard about, and there's like a number of ways we can carve up this space of particular methods. One is that we can say that some of these are just defined by humans through simple rules or very complicated rules, but many of those are data-driven. They're sort of learned from just raw text. Then there's simple models like the ones we like to use for subword stuff, and more complex models. I'm not going to go into too much detail on that for now. Another direction we could carve up this space is in like something that claims to use linguistic concepts or actually requires linguistic knowledge. So this contains, of course, manually created analyzers, but also things like morphethers that still use some kind of data-driven approach but are informed by linguistics, all the way to even old-school tokenizers like the Moses tokenization. They still contain some level of linguistic insight. Yet a different way we could carve this up is by saying, look, some of these are basically just saying, whatever, just do the simplest thing you can imagine. Decompose units, maximally. So this might lead you to characters, really, I suppose, to bytes if we want to look at the UTF encoding or stuff like that, or in other approaches to rendered pixels. So that's kind of the spectrum where things are in. Yet another lens we can view things on is like, do they require words to be provided and try to split those words or analyze those words further? Or do they just claim to find word-like units? Is the token that is being created essentially a word? And of course we can put this all together in one big figure, and that's basically the figure 1 of this survey. So what's the order that we're going to cover all this in? We're going to try to follow this rough thing that I've split in on the right. We're going to start with pre-tokenization, so really this old tokenization scripting thing that's basically space splitting, but perhaps a little bit more. Then move on to just models that try to, yes, use these word-like units, but also not treat them as atoms, but include characters. That'll lead us to a bunch of work that tries to find these word-like units automatically. That work is then sort of extended, or perhaps more recently used for finding subword units. And finally, we will talk about what I suppose is really the thing that a lot of people have a lot of interest in these days, although it would be kind of foolish to say that it's the only viable option for the future, and that's characters, bytes, and pixels. So, as we said, we have a draft. There's a lot of stuff in there. The overall scope, I think, is pretty clear. The sectioning hopefully makes some sense. We cite a lot of papers, but there's still a lot to do. We still need to look at a bunch of more papers, decide on some topics we might want to cover additionally, and then polish the thing and put it to archive, and hopefully then also submit it to a conference. But I think putting this out on archive is our first priority. Hopefully we'll have a draft sometime in the next month or two. And that's it from me. Thank you.
I will now present some of our preliminary investigations on the effect of corpus size on tokenizer training. Tokenizers are usually trained on the entire training corpus, but with the rise of increasingly large language models, the pre-training corpora have also been rapidly increasing in size. As a result, even an efficient training time complexity can be non-trivial in practice. This led us to question whether we really needed to train the tokenizer on the entire corpus. Due to the relative simplicity of our tokenizers, we hypothesized that there exists a point at which increasing the training corpus size has little to no effect on the tokenizer's performance. If such points exist, we will be able to reduce tokenizer training times, and there will also be smaller disparities between the high and low resource languages in the training set of multilingual tokenizers. At the moment, we use common intrinsic metrics for evaluating tokenizers, such as average sequence length and UNC rate. In this set of experiments, we train monolingual BPE tokenizers for 9 languages from the OSCAR corpus with 2 vocabulary sizes. As we can see from the graphs, the average sequence length stabilizes rather quickly for all languages, around the 1 GB mark. The UNC rate takes a little longer, with all but one language stabilizing by the 8 GB mark. However, it's also important to note that the fluctuations in UNC rate are actually quite minute. We observe similar trends for the larger vocabulary size of 30K. Next, we are planning to extend the experiments to more languages, check if the findings generalize to other corpora and tokenization methods, and test if the intrinsic metrics correlate with actual model performance.
Hello everyone, I'm going to talk about some experiments we are doing on scaling laws for tokenization strategies, which is joint work with Arun Raja, Benoît Sagot, and Samson. So basically the idea is that we are going to try different tokenization strategies, and we would like to select the one that, that gives the best performance at the end for the final large model. The problem being that we cannot train a large model, and we cannot train several large models to see which one performs best. So we have to restrict ourselves to smaller models and test the strategies on those smaller models, and then extrapolate to the final model. The main problem is that if we only have 1.1 small models, it's really hard to say if the performance of one tokenization strategy will really carry to the large model. So the idea to solve that is to use the scaling laws. Scaling laws dictate that basically you have some high correlation between the model size or the amount of data it was used to train a model and some performance metric, in particular the loss or perplexity for a language model. So the idea of the project is to train several smaller models, find these correlations between model size or corpus size and the loss, and extrapolate to the large model to see which strategy will be the best at the full size, at the full model size, without having to ever train one large model. So what do we want to try exactly? What are the strategies we want to test out? So there are several. Basically, we've identified 5 strategies for the multilingual tokenization. The first one is to train with all the languages, all the corpus, and have a tokenizer out of it. Then we want also to try training one tokenizer per language, then taking the union of vocabularies created. Another idea, which is from recent work, is to cluster languages based on specific attributes, and then create one tokenizer for each language and take the union of all these tokenizer, all these vocabularies. Then we would like to try one tokenizer per script, for instance, one for the Latin script, one for the Chinese script, and put every language belonging to one script in each of the training data for each tokenizer, and then take the union once again. And the final one is kind of a baseline, which is to create a tokenizer which has a vocabulary which consists only in characters, Latin characters, Chinese characters, and so on. Then the second dimension we want to try out is the vocabulary size, because large vocabulary size are good for memorization and it helps the models. But it also creates some kind of token sparsity in the training data, meaning that some words will be seen very often, very rarely when training, which is problematic. And finally, to carry the experiments, we try 2 axes, as I said before. We will vary the number of model parameters, probably between 11 million and 1 billion parameters. And we'll also vary the corpus size and try to sketch scaling laws based on those 2. We'll use models that correspond to what the modeling working group is currently thinking about, which is either PrefixLM or GPT, with GPT being already in the Megatron Deep Speed repository. And finally, we will test out not only the perplexity, but as well downstream tasks for the scaling laws, which correspond better to the performance we want to get out of the model at the end, because the perplexity is mainly used during training, but not necessarily after that. So we'll probably use XNLI for the languages that are in the BigScience languages, and maybe dependency parsing for the rarer languages.
So in terms of next steps, we plan to conduct the scaling experiments in collaboration with the engineering and modeling working groups. Then we'll also design and carry out an experiment plan for evaluating tokenizer fairness. Finally, we also want to choose the tokenization strategy for the model training experiments that the modeling and engineering groups will be carrying out. So if you're interested in joining us but are not yet a member of our working group, please